we are asked to solve this. So we are asked to find the solution of that. So we can write this as x squared raised to power 2 minus 1 equal to 0. That's moving 1 to that side. So this difference of 2 squared, so which is the same thing as x squared minus x squared minus 1 times x squared plus 1. That's using difference of 2 squares. From here, the product of two numbers to be 0 means one of them must be 0, but we don't know which one. So it's either the first one is 0 or the second one is 0. So here, so this is also difference of 2 squares. So x minus 1, s plus 1 equal to 0. Y here is okay, this x, maybe x squared equals minus 1. So this, from the first one, x is 1 and minus 1. That's equating the 2 to 0. Why this? X is now square root of minus 1 plus or minus, which is plus or minus iota. That's I. So our answer is 1 minus 1 minus I and I. So that's our answer. Has 4 answers. So the next question, we're asked to find sine x. That's to check whether each one of these is the value of sine s. To solve this, we will remember our Euler's formula that says that e raised to 4 ix, because they are using x here, is cos x plus I sine x, and also minus is cos x minus I sine x. So equation 1, equation 2. So if you add equation 1, if you add, okay, let's subtract. If you subtract, means ix minus ix, this minus this is 0, so this minus minus, so we have I2 sine x, which sine x is now eix minus ei minus ix over 2I, or I2. So the answer is, seems none of them is the answer. Maybe we omitted something. Maybe this should be the minus. So this should be the minus. So the answer is D. It must be negative. Again, if you add equation 1, let's get something, because we're going to solve something like that using it in solving tan. If you add equation 1, we have eix plus e minus ix must give us 2 cos x if you add. So if dividing both sides, we have that eix plus e minus ix over 2 is now cos x. So let's now solve this using that. We now see that tan, from our trick, tan is sine over cos, and we've gotten that sine is eix minus e minus ix over 2I divided by, that's times our cos is now divided, we reciprocate, so 2 over eix plus ei minus ix. So we reciprocated because cos is this, so I had to, cos is that, so we decided to reciprocate division, so which is now this, so we have eix minus ix over eix plus e minus ix. So looking at the option, It's not this, it's not that. Okay. Don't be quick to choose none. If you notice, this is 1 over I. 1 over I. Numerator and denominator by I. We have I e I x minus I x over I times I is I squared, and I squared is minus 1. So we have minus, so minus bracket e I x plus e minus I. So looking at this, the minus will go up. So our answer is C. That's the answer. I over minus 1 is minus I. So that's why I say don't be quick to choose D. The next question, we are asked to express this in standard form. Express this in standard form. The first thing we'll do, we need to convert using this. If you could remember, this is cos pi over 3 plus I sine pi over 3, which is this 60 cos 60 is half plus I root 3 over 2 sine 60 is root 3 over 2 pi over 3. So we now multiply 4 plus 6I, or let's write I6 times half plus I root 3 over 2. So let's multiply. The fastest way of expansion, 4 times half is 2. 6I times I6 times half is I3, so I3. 4 times I root 3 over 2 is 2 I2 root 3, because 2 and 4 2's. Finally, I6 times that, I times I is I squared, so minus 1. 6 times root 3 over that is 3 root 3, which is 2, there is no, which is now 2 minus 3 root 3 as our real part, and finally plus I3 plus 2 root 3 as our imaginary part. So this is our real part. The answer is 3 2 root 3. So the answer is B. Our answer is B. The next question, if one of the arguments of the cube root of a complex number is pi over 2, then the remaining arguments is very simple to solve. If you could remember, the nth root of a complex number, the angle which is the argument, is always theta plus 2 pi k over n. So you notice that each of them, which is like theta over n plus 2 pi k over what? N, meaning that they differ by 2 pi over n. 2 pi over n. So if the first one is pi over 2, one of the roots, let's try and add 2 pi over 3, because n is 3. So let's know what we get. So this is 6. 3 pi plus 4 pi is 7 pi. So one of them is 7 pi, and the next is 7 pi over 6 plus 2 pi over 3, which is 4 pi plus 7 pi, 11 pi over 6. So the answer is this: 7 pi over 6 and 11 pi over 6. So each of the argument differ by 2 pi over n. Very, very important. The next question.